Hi, this is Irv Shapiro of the Dr. Vax channel, and today we're going to assemble and review a big printer. This printer, as you can see from this Z-axis, is 400 millimeters tall. That's the print area. And the print bed, and I can show you here, is quite large at 300 millimeters square. I believe that's basically a CR10 size 3D printer. Specifically, this is the ANET ET5. Now, there's a bit of a story behind this. I did a review of the ANET ET4, the base original model, before COVID. And ANET must have liked my review of that printer back in the February timeframe of this year, because in May, unannounced, unrequested, an ET5 showed up at my door. Now, I didn't pay for this ET5, and in fact, I didn't pay for the ET4. Both of these are review models. It's interesting to me because my review of the ET4 was that overall it's a really solid 3D printer for the price, and you get a lot of hardware for your money, but the firmware still was a work in progress. That the firmware does a very good job of producing quality prints, and in fact the ET4 is faster than some of my other Bowden style printers, but the firmware did not have the capabilities to calibrate the printer. So when ANET sent me the ET5, I sent him an email saying, I just got this printer from you, thank you very much. I'd like to do a review, but I have this concern. And we went back and forth over time, and they said, keep watching, news is coming. And then about 4 months ago, ANET started cooperating, it might have been 5 months ago now, started cooperating with the open source community to port a version of Marlin 2.0 to their printer. And about 3 months ago, Marlin 2.0 was now available. But the only way to install it on your printer was to open up the printer and use a specialized piece of hardware, and I'll explain that in another video, and install it. And if you wanted to upgrade it, because Marlin was still new for this printer, you had to do that every time. Well, now there's a version of Marlin for this printer that, yes, you have to open the printer the first time to install it, but after that it has a bootloader. That's a piece of software that allows you to update the firmware off the SD card. So I'm ready to begin my journey with the ET5. In this first video, I'm going to review the printer using the stock firmware, the software that comes from ANET. And then in a future video, I'll show you how to upgrade your printer to Marlin 2.0 and take advantage of the latest firmware features in the 3D printing industry. So stay tuned and let's learn something together. Now, before we get started with this review, since this is going to be a series of videos about the ET5, if you're interested in ANET printers or the ET5 or 3D printing or woodworking or electronics, any of the things I cover in over 150 videos on the Dr. Vax channel, please subscribe to the channel. It really helps me out. Click on the bell so you're notified about new videos. Now, this printer comes in a big box. And I've taken it out of the box so it'll fit on my work area here. And let's go through what comes inside. Obviously, there's a bit of paperwork. The setup manual and the user manual are really pretty skimpy. And the reason the setup manual is so skimpy is that ANET printers might be the easiest DIY printers available today. They don't claim to be fully assembled because they're not. But basically, all you do is you take the gantry, sort of looks like a picture frame here. You take the gantry, you screw it, you bolt it onto the frame, and you plug in some cables. And the cable management for the ET4 and the ET5 are really very, very well done. Now, in addition, something pretty surprising, at least with the ET5, because I did not get a full roll with the ET4. I got a full roll of black PLA filament. The print bed on this printer, which is 300 by 300, is a sheet of glass. And it fits onto the printer with 4 clips. And then they ship a sheet of material. It says 3M on the back. I don't know whose material this is on the front. It looks almost like a build textile material that you glue onto the top surface. Now, I assume if you want to, you can print directly on the glass if you prefer that. In addition, one of the things I noticed right away with this printer, very different than the ET4, is that there are dual Z-axis motors. This is going to make this a very stable printer. Overall, I find the ANET printers are built really well. They're rock solid. There is only one part on this printer that looks like it might be 3D printed, and that is on the pre-assembled hot end assembly, which just we'll see slides on here. On this hot end assembly, it looks like the fan shroud is 3D printed. As a matter of fact, I can see the overhang here. That may be because they're fine-tuning the characteristics of this fan shroud. And there's actually a little bit of stringing here that I'll pull off before I use this. Now, the hot end on this printer is different than my ET4, primarily because there's a built-in auto bed leveling sensor. It's probably an induction style sensor. I can tell from the adjustment on the top. And in fact, interestingly, if I look at this printer, I couldn't find the Z limit switch. Now on the ET4, the Z limit switch is on the top, which means that to home the Z axis goes all the way to the top and then it measures its way down. That's an unusual design. You don't see that in a lot of printers. On this printer, my understanding is that the Z axis homes on the way down, and the way it does it is this sensor just tells it when it's approaching the print bed. So very, very interesting how this is configured. All of the cables are well marked. The Bowden tube for the hot end is already assembled. That's good because the Bowden tubes on the ANET printers are like the Creality Ender printers. They go all the way down to the nozzle, so you have to be careful when inserting them. Now, unfortunately, one thing I really do not like about ANET ET printers is the Bowden tube is a non-standard outside diameter. Standard outside diameter on a Bowden tube in the industry is 4 millimeters. That's what Capricorn tube is, which is something I like to upgrade my printers to. This is 3.8. So in another video on the channel, you'll see I tried to update my ET4 to Capricorn tubing, and I failed because it wouldn't fit. In addition with the kit, we have a belt for the X-axis, and it comes with a side clipper. This is sort of humorous. These side clippers that ANET ships say made in the USA, which means they're made here, shipped to China, and shipped back. But either way, you can tell the assembly is easy because this is all the screws there are to assemble this printer. If you've assembled other printers, let's say an Ender 3 or an Ender 5, there's a lot more work. One of the things that surprised me is they ship this really nice paint scraper print remover that's very sharp. Now, my go-to way to take prints off non-flexible print beds is a paint scraper, the type you might use around your house with a razor blade in it. This is as sharp as that. I think this is going to be my new go-to device. They do ship a couple tools. I generally don't like using the factory-provided tools except for the little wrench, which you use for adjusting the eccentric nuts, the nuts that move in and out on the various wheels so that you can get the tension correct. Instead, I like to have a couple screwdriver style Allen wrenches. This is a 3 millimeter and a 2 millimeter that I generally will use. Finally, they ship you a little ruler. Now, why do they ship a ruler? Well, remember, there's no Z-axis switch on here, and I have dual motors. So I need to make sure I adjust those two start positions so they're the same height from the print bed, and we'll show you how that adjustment is made. Okay, other than that, let's see what's left here. We have a filament reel holder. That's obvious enough. And I think that's about it. So I'm going to go off camera now. I'm going to flip this over, bolt this in place, connect the connectors. And then we'll set it up together, and I'll show you how to do initial calibration on this printer for bed leveling, something people at times seem to have difficulty with. Then we'll go and make some prints and see how it works out. Okay, I'm back after assembling this and letting it run overnight and printing some prints so we could see how this printer operates using the firmware provided by ANET. Now, assembly of this printer is as easy as I remember on the ET4. There are literally 6 bolts on each side that hold this gantry onto the base. There are 2 underneath, 2 in the front, 2 in the side. That's it. Then you plug in a series of cables. The cables all plug in very, very easily because on this printer, right back here, and I'll show you a picture of that, there's a board with well-labeled connectors for all of the cables. And then a single ribbon cable, it's this ribbon cable here, I'll also show you a picture of that, goes from the control board inside the printer to this particular daughter board, this extra board, this breakout board. So this is by far the easiest self-assembled printer I've ever worked with. As easy as the ET4. The only difference is this is quite large and so a bit unruly to work with. Now, once you assemble it, calibrating the bed, that's another story. That's a little bit tricky, so I'm going to walk you through how to do that. So instead of spending lots of time showing you about alignment first I'm going to bury the lead. Let's look at print quality. So the first thing I printed, and I'll show you a close-up of all these prints, these were in black, the black PLA provided by ANET, which seems to work just fine, was a vase that was on the SD card. This was a vase that I had to move from an inside directory to the root directory. It printed nicely, but not perfect. And one of the things I noticed was there were some defects that seemed to happen at the same place consistently. So I was wondering what was causing those defects. Well, when running the printer, and I'll show you a little video here, I noticed that on the extruder, the component that pushes the filament to the hot end, there was a grub screw, a little set screw in the gear. Now the gear looks like a really robust solid gear. That grub screw or set screw was hitting the side of the extruder housing. Now there are 2 grub screws, so the gear was tight, but it ends up that one wasn't screwed in. So I screwed it in, that solved the problem, it stopped hitting, and in later prints I didn't see this defect in the same place. Now, the next print I printed by taking and scaling up a frog that I quite like. This is sort of the thinking or the board frog. I think it's called the board frog on Thingiverse. I scaled this up quite large, and it took about 8 hours to print. Now to put that in perspective, look at that relative to the size of this printer. Now this took 8 hours. If I was going to print a solid item, not a vase, but a solid item, the full size of this printer, it would take days. So it's very nice to have all this size when you need it, but you need to recognize it's going to take a long time to print things this big. This print came out quite nice. I did notice a couple things. The profile I used was for Cura 4.7.1. I've done some other prints on Cura 4.8 using the ET5 profile I found in Cura. Now, I believe the number of outer walls, the outer wall settings are a bit too thin because I can see the infill, at least through this black PLA. And there's quite a bit of stringing. Other than that, really a very solid print. And while I was a little bit nervous about letting a brand new printer go for 8 hours, it went for 8 hours without any difficulty at all. Now, one of the advantages of the new ANET ET4, AT5 printers is they do have protection in the new 32-bit control boards to ensure that if your heating element starts running away, it will shut down the printer. Another nice feature it has for long prints is it has a filament out detector. When you run out of filament or you lose power for some reason, the printer does properly restart where it left over. So then I wanted to check quality using a filament I know. So I loaded some Hatchbox white PLA, and because there was a lot of stringing here, they had in the default profile, they had the retraction setting at 3.5 at 40 millimeters per second. I changed that to 6.5 at 25 millimeters per second, and this calibration cat printed quite well with almost no stringing at all. Now, the reason you print a calibration print like this is to see how well tuned your printer is. So in this dimension, I'm at, I don't know if you can see it here, but that's 20.12 millimeters. Not too shabby, less than 1% off. And in the other dimension, it's exactly 20 millimeters. So this printer is pretty darn well tuned in. In the next video, I'm going to show you how to install Marlin on this printer to take it to the next level, because you'll have a series of new features. But we've tested the hardware now. Let's put these aside. And let's show you now how you set up bed leveling on this printer. Now, the first thing I'm going to do with the power off is I'm going to manually, by turning both of these rods at the same time, move the print head so it's just above the print surface. Now, I like to use a Post-it note to get the right distance. So I fold the sticky half over itself to give me a little bit of a handle. And then I can sort of slide that under there. So I'm going to move this down until it just touches the Post-it note. And right now I can't pull it out at all, so I'm going to back it off a little bit. I really only need to back this one off right now. I'll show you why in a second. And I want it to have some resistance but be movable. So that's telling me that this corner, and you could start in either this corner or this corner, but this corner is about right. It's about leveled. So now I need to make sure that this distance here, this rod, is the same distance on both sides. So they recommend using the little ruler they provide you in order to adjust that. I like to use a little bit higher tech approach. So I'm going to take out my caliper here, my digital caliper, and I'm going to measure the distance here. And I have 71.26 millimeters. So now I'm going to go over to this side and I'm going to measure the distance. And this is 70.1. So we need to increase this a little bit. When you turn this rod to the right, the gantry goes down. When you turn it to the left, it goes up. Now that this distance on this side and this side are the same, once again, you could use a ruler to do that. You want to never again touch these manually. So I use those manually to initially put them in position, but now I do not want to touch them. So I'm going to double check that this corner feels about right. Now, I'm going to completely manually, with the power off, get the other four corners close. So I'm going to press down on the print bed. That's going to compress the springs, and I'm going to very slowly move it to the next location. Then I'm going to slide my paper under it, and I had already leveled this, so it's pretty close. And so hear how that's scratchy? That's exactly what you want. Now, that we're relatively sure this is in the right place, we can proceed with using the electronics to fine-tune it. If you don't do these steps first, and the next step I'm going to show you about calibrating the sensor, then your printer may jam right into your print bed the first time you turn it on. And so the first time you turn on that printer and you hit home, which will cause it to go to the home position, make sure you're ready with the power switch. So I'm going to move this over to here now, and I'm going to turn the power on, and we'll see the red light is on. Now that means that the sensor is sensing the bed. But in order to get consistent behavior from the sensor, I need to make sure it's the right distance from the bed. Now, they say in the user guide that it should be 2 to 3 millimeters. I like it at 2. At 3, I found there was a little variability. Each time I ran the calibration procedure, it seemed to change a little. At 2, it seems to be pretty good. So how do I get 2? For 2, I find that using a doubled up Post-it note on top of this ruler is the right height. So I'm going to see if I can slide this underneath here. And it should be just fit underneath there. And if I can, it's that sensor's the right height. Now, if it's too high or too low, there's a screw over here. You put this in here, and then you can move that sensor up and down. So I have the right distance from the print surface. I'm going to move this to the center now. I'm going to power my printer on. The red light's on. Now I want to adjust it so the red light is just going to come on when it gets to that position, because we're leveled now, we're at the right height. ANET provides you a screwdriver. I didn't find that one fits very well, so I have a little bit smaller one, and there's a screw on the top of this sensor. You want to turn the screw to the right until the sensor goes off. Whoops. Then you want to turn it back to the left until it just comes on. Off, on, off, on. That means that it's now calibrated. We have it the right height from the bed, and it's calibrated for this. Now that I've completely manually leveled this, I haven't used any electronics really, other than calibrating the sensor, I can be comfortable about turning the printer on and telling it to go to the home position. There are limit switches on the X-axis, and there's a limit switch on the Y-axis that's going to keep it from moving where it shouldn't move. And I know my sensor now is calibrated, so it's not going to plunge into my print surface. Now, before you start any of your final bed leveling procedures, the manual or the automated, it's recommended that you heat up your print bed to about 60 degrees Celsius. The reason for that is that things expand when they're heated. They contract when they're cooled, they expand when they're heated, so the distances will change a bit. If you don't preheat your print bed before you calibrate it, you may find your nozzle too close to the print surface when you go to make your first print. The end result is the first layer won't print successfully because there's no room for the filament to come out, and you may actually hear your extruder clicking. Okay, so power on your printer, select prepare, select level. You'll see two options, auto and manual. We're going to start with the manual option. I'm going to press the manual button once. In some earlier versions of the firmware, you had to press it twice. I'm on 1.1.6. I'm going to get a Post-it note ready. And I'm going to place the Post-it note under the nozzle, but not under the sensor. So you'll see here that it positions it where it thinks home is. And this is a little bit tight. I can't pull this at all. So if it's a little bit tight, I want to raise it up. So I'm going to hit the plus button. We'll hit it a couple times here. And then I'll check it again. And it's better, but still a little too tight. And now, whoops, we're too loose. So we'll go minus a little bit. And hear that sound? That's just about right. Now, I can go to each of the individual corners. So I'm going to press the 1, and it's going to move this to the corner. Now, for the corners, I don't use the numbers. That's the Z offset for the center. For the corners, I just use the knobs, the same way we did before. So let's get those set. And if I have to adjust these knobs a lot, it's going to change the corner. We're going to reset the center again. So that seems about right. Let me go to the next corner. Now, once you've done that, and you have to do it a couple times, don't get frustrated. This is going to be worth your time to do it right. Then click on the OK button. That's going to move the printhead back to the home position, and we can double check our Z offset. Ooh, that feels just perfect. Okay, so our printer is now leveled, and we could go ahead and start printing. But there is a feature to use this electronic sensor to have the firmware micro adjust the leveling. So instead of just checking these 4 spots, we can check 16 spots across this printer and create a matrix of numbers of offsets that will be added to our Z offset when we go to print. So let's go ahead and do that by clicking the auto button. You have to click it twice. After you click it twice, you should get a message on the screen asking you if you want to start auto bed leveling. We're going to say yes. What it's doing right now is moving up quite a bit to make sure that the sensor can be triggered properly when it moves down. So it is normal for it to move way up and then move back down. So the printer now is going to the first spot, and it's going to use the sensor to gauge how far it is in the down 0 position from the print bed. So you'll see it doesn't hit the print bed. It stops as it gets close to it. Then it's going to move to a second position. It's going to do this 16 times. This takes about 6 minutes. Now that the printer has completed the auto leveling, it says completed. I have to click on OK, and you'll see 9 numbers on the screen. If those 9 numbers are within plus or minus 0.5, your print bed is sufficiently level to use the auto calibration. And then you click OK. When you click OK, the printer is going to home the printer, and you use the post-it note trick again to set the Z offset. So now, and it's already perfect, so I don't have to adjust it. If I needed to adjust it, I would use the plus or minus keys to adjust it, and then when I'm all set, I just click OK. Now each time you click OK, it's going to rehome the printer. But if it was properly set, you're all done, and now you can just hit the back button on the display, and you're ready to print. So I'm going to go ahead now and start a print very quickly just to show you what that process is. You go to print, you select the item you want to print. We're going to select the item for the CaliCat. Then you press OK. Okay, we can see here that we printed a waste or a purge line. And if I go to rub on that with my fingers, it won't come off the print surface. We're now printing the actual print. So what are my impressions of the ANET ET5? Well, just like the ET4, the hardware is great. It's really, really solid. The features you get for about $330 are really very strong. You get a filament out detection sensor. You get a 32-bit control board. It has a auto bed leveling system. It has a really quite a good extruder, excellent gear for pushing the filament through. It is very easy to adjust all of the tension on your belts. Every place there's a belt, I don't know if you can see that here, but there are ways to adjust the tension on the belt. Very, very easy to work on this printer. It has dual Z axes with stepper motors. The print quality is good. It's not the absolute best I've ever seen, but it's really very, very solid. So for $330, you're getting a lot of printer. The only negative is that the standard firmware isn't quite finished. We can fix all of those things by upgrading this printer to Marlin version 2, open source 3D printer firmware from the firmware that comes with the printer. So that's what my next video will be about. I'll publish that video if I can successfully upgrade this printer. And then this goes from being a really good value printer at $310 to potentially a best-in-class printer at $310. Well, folks, thanks for watching. I hope you enjoyed this video. And if you did, please subscribe, give me a thumbs up, recommend this video to everyone you know, send the link around, and let's continue to learn things together.